Okay, I'm making a video tutorial for how to use shaders, and I am re-recording the audio right now because I screwed up several times before and it was horrible. Okay, so I want to start with defining some matrices. First I will get the view matrix because that's what defines like from where we look at which point or to which point, and the projection matrix then turns the stuff that has been transformed, translated and rotated by the view matrix into screen coordinates, which are then mapped by the rasterizer to pixels on the screen, and the values are interpolated and then the pixel shader takes it. So we will use these matrices in the vertex shader. Then it will go through the rasterizer and the interpolator and end up in our pixel shader. And the pixel shader then determines the color of the pixel on our screen. Then next is our effect class, which wraps around the shader. Then we have a list of vertices. These are vertex position texture. These vertices they consist of a position and a texture position. And then we have indices, which are just integers. Then next we declare our matrices. This one is a view matrix, so we have create look at. We will start at some point, let's say 20, 0, 0. And we will look at a point a bit above the origin, I think 0, 5, 0 or okay, 0, 2.50. And our up vector is just the normal up vector. You can change it, but it rotates the whole coordinate system basically for what you're looking at then. Then our projection matrix is a create perspective field of view. And this takes the field of view. We want this to be 45 degrees, which is math pi divided by 4. Then the aspect ratio is something we can grab directly from the graphics device because it declares it properly. Right? Viewport. Viewport. Aspect ratio. Again. Alright, then the plane distance and the far plane distance kind of cut off everything that's not in between those two values of distance. Then next we want to initialize our vertices. I mean, we first have to create the list, obviously, then we just add some new vertex position texture. Now you see they consist of a vector 3, which is the position. Let's see, 0, 5, 0. And a texture coordinate. Let's say this one is 0, 0. Okay. I missed a bracket. Now we will add some of them. Because I'm lazy, I copy and paste because I only need to change the numbers around. Okay, so these become 0. If you imagine the coordinate system, we are looking at it from the right side. So now we want to offset stuff along the z-axis so that we directly look at the triangle and do not rotate it along some axis or stuff. For the indices, we just add 0, 1 and 2 because we only have 3 vertices. It's kind of obvious which vertices make up our triangle. Right, that's done. Then we want to load our effect. We will load it from the content. Load effect. And then let's call it shader. But we haven't yet created a shader. So what we will do is we will create one. Now you just choose effects. I would name a shader for this tutorial, but I added it to the wrong project because I already made one before. Okay, so again, effect file, let's call it shader.fx. And here we go. This creates the basic stuff. The world, view and projection matrices are defined. I already explained what they're for, I guess I will explain again. Then we have the input for our vertex shader, but we have not just positions but texture coordinates as well. So we want to add that as well. The stuff behind the colon defines which value in the struct means what. The world matrix, oh god, it's hard to just watch yourself explain stuff. The world matrix is the translation, transformation and rotation of your object. If you have a lot of vertices, you want to use a world matrix. So you do not have to transform them on your CPU, but instead you can just pass the world matrix to the GPU and it will transform all vertices in the same way, which is kind of like moving the object in your world. That's why it's called world matrix. Then, as you can see, it's vertex position texture. So we want a position and a texture coordinate. The same thing is true for this one. We have the output of the vertex shader, which is also the input of our pixel shader. We will get the position and the texture coordinate in the pixel shader, but the position is rather useless. I mean, it's quite useless really. Then here's our vertex shader function. It creates the output and then transforms everything. And here's our pixel shader, which just prints stuff red. The colors are RGB and it's 1001. So we have red at 1 and no alpha. Okay. Then here we have, oh god, I'm going to sneeze. Okay. Then as you can see, we just return red. Then the input, the output, and we want to change a bit about this shader because we want to pass the texture coordinate just through to our pixel shader. So all we do is output.textureCoordinate equals input.textureCoordinate, and boom, it gets returned as well, and we get it as our input for the pixel shader function. Then, because we want to do something a bit more fancy, we will draw the sign of input.textcore.x, and well, the times 10 belongs inside the brackets, but I will change that later. Okay, I'm copying again because I'm so lazy. Here we do it for y, and here we do it for, yeah, now I notice. Okay, x plus input plus textcore.y. Now I set some brackets to get the things right. Okay. Brackets, brackets, brackets. Good. Now this should get stuff a bit more colorful. Then let's see our pass and everything. It looks fine so far. When you're using XNA 4.0, you can only use vertex and pixel shaders 2.0 or later. All the support for 1.0 or 1.1 has been deprecated. Okay, now we add a function to draw our triangle, or rather triangles. Like I already set it up so you can draw more than one. Because I used the list and stuff, it makes it really easy. Now we create the vertex buffer. And the vertex buffer basically wraps around your vertices and tells the framework how to interpret them. Yeah. So we tell them it's vertex position texture, vertex declaration. Then our vertex count is vertices count, because we have as many vertices as there are in our vertices list. Then buffer usage is none, because we do not want to use this one for any special purpose. Then we also create an index buffer, which wraps around our indices. It's fairly simple. Then our index buffer, it also wants a graphics device as the vertex buffer does. Then our index element size, or the type of our index type. So we do type of int. Then our index count is indices.count. And our buffer usage is, again, it's none, because we do not want to use it for anything special either. So now we set the data for our vertex buffer. It's set data, vertex position texture, then this goes on and on and on. Okay, we just change our list to an array and pass it as data to our buffers. Same goes for the integer values. So it's indices to array, not like I did here. It's funny to watch yourself code, really. It's like, what? Dude. Okay, so we get this to an array. We basically have the buffer set up yet, or rather now. Then we will iterate through all passes in our shader effect. And the thing is, we only have one, but you generally want to do this if you want to like write a rendering engine or anything. It's useful to just go through all passes anyway. It's not much overhead, but it simplifies stuff, so you do not bug too many things if you change your shader around and stuff. Okay, so now we set our vertex buffer, then we set our index buffer. The order doesn't really matter, just we set them before we draw. And now we draw index primitives. And our primitive type is a triangle list. Then our base vertex is 0, our min vertex index is 0. These are basically offsets to the index. I mean, you can read it down there, I guess. Then the number of vertices is vertices.count. And our start index is also 0. It's an offset to which indices to use. God. And this is indices.count divided by 3. This is the count of primitives. If we have 3 indices, we have 1 triangle, because a triangle consists of 3 vertices. Okay. Then our shader effect needs to be set. So we set the current technique to, what was it called? Technique 1. Hooray. Okay, so we use shader, effect, techniques. Do it. Techniques. Good. And then technique 1. Okay, now we also want to set some parameters. We call them world, view, and projection. Our view matrix will be view matrix. Then I copy it because I'm lazy. Our projection matrix will be 10 seconds to guess. Projection matrix. Okay, this weren't 10 seconds. I should have said 2 or something. Okay. Then we also set our world matrix. This will just be the identity matrix for now, but if we had lots and lots of more stuff, it would be really helpful to do that. Okay, matrix identity. I don't know what I explained here. Really? Okay, this should work. Actually, it does work, except for 2 small details. I am calling the wrong project. So at first it seems to work because I basically did the same thing again and just took you through all the steps from the beginning. So now you see something that works, hooray. But as you can see, the background is black because I changed it at the other project. And now in the original audio I was like, yay, it's working. And this project is working as well, but I forgot to add the draw call to the, don't let me lie, I added the draw call to the, I didn't add the draw call for the triangle into my game's draw routine. So it's never called, and like you can see me backtracking where everything goes wrong. At this point in the video I wanted to like just explain everything I did again, so like kind of a roundup. The thing is, I didn't add the draw call, and then when I tried to change something, I add another vertex now, because I want to not draw just a triangle, but I want to draw a quad, basically. Okay, so I add another vertex, and I add 3 more indices, because a quad consists of 2 triangles, but only of 4 vertices. So I'm explaining like this is drawn, this does this, and then in the original audio I said something like, oh wait, I can just do this, because the way I programmed this, it should just work. So do I do it now? Or okay, yeah, there we go. Now I add another vertex. It's just the very same thing, and I just replace, or I just move it a bit downward, and I set the last value for the texture coordinate. Then I add the indices. You have to be a bit careful here with culling. Like, you have to think about, okay, in which way does my original triangle rotate? I mean, if you have your first vertex and go in that direction, it's either rotating clockwise or counterclockwise. So you want this to rotate in the same way, because otherwise, if you use culling, which you probably want for performance, then it can very well happen that you aren't getting stuff right. Now you see, I ran the wrong project, and now I got a bit confused, because that's nothing you expect when doing this. So I changed this around. I think now it should actually rotate in the correct way, but I'm not sure. So I'm changing the cal mode to none. Rasterizer state equals rasterizer state cal none. As you can see, it cals either clockwise or counterclockwise, or just nothing at all. But now it doesn't run, and I'm like, WTF. I had no clue what on earth was going on. It took me like ages to figure out what the issue was. Okay, so I'm going through all my code. You can see me check if the draw triangle routine is right. Then I'm checking if the shader is loaded correctly and everything. And that everything of that seems pretty fine. I'm changing stuff around because honestly at this point I had no idea what was going wrong, because the code is basically right. I mean, it really is. So you can see if you compile again, and I'm like, what's going on? But I think I will notice soon. Maybe, I hope. Because in the first 15 minutes I got everything working basically, except the draw call and calling the wrong project. So this was kind of embarrassing. I think, do I change the return value? No, I don't. Okay. So let's see how long it takes me to figure out. Now you can see that the draw triangle routine is missing very clearly. Oh my god. Okay, now I figured it out. But I didn't see that I'm not calling draw triangle. And now I'm running it, and there's nothing on the screen. And I'm like, oh god, this is even worse. Okay. So I will check everything again. Just for the fun of it. Oh god. I'm not sure if I should make a video if I get confused about easy stuff like this. Now I'm comparing it to the other one, which is running. And what I'm saying here is it's basically the same. In fact, it's not just basically the same, it's very much the same. The only difference is that in the shader, which I wrote like from hand, I used a view projection matrix, which was kind of static. And here I use separate matrices. I guess this is more performant, but I'm not quite sure. I mean, if my view matrix only changes once in a frame and my projection matrix never changes, it's probably easier to calculate it on the CPU once than calculating it on the GPU for each vertex. But what do I know? So my identity matrix, everything seems fine. The draw triangle routine is perfectly right, and I just forgot to call it. And it takes me several minutes to figure this out. You can see me like go through my code, change stuff, get all confused for like 3 more minutes, I think, so enjoy. I might add some music in or something. La 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 la. Okay, now I want to draw a triangle that's just red. Nothing. Hooray! Oh, it's kind of funny, but I'm not exactly feeling good about myself now that I watch this. Okay, so let's check everything again. Everything is initialized properly. The indices are set correctly. I don't even cull anything, even though I guess I could. I load the shader correctly. I initialize the values. I have my matrices set correctly. Then draw triangle looks perfectly alright everywhere. I set up my vertex buffer. Now you can see the difference. There, draw triangle is in my game draw, but it's not. I'm like comparing this over and over again. I'm like, okay, I'm doing the exact same thing, and I'm sure this should work, but why does it not? I guess I should just have set a breakpoint and see that it never enters the draw routine, but I didn't want to go all debugging on the video I made. It was supposed to be a nice video. Okay, let's see. When do I notice? Okay, I don't think it takes me much more time. Yeah, now I went to change every value to the exact same thing it was in the original one. Then I decided, no, that's a bad idea. And I recompiled because I was thinking maybe in my head everything is wrong and I have the vertices set to values which are like completely in the same direction as the direction I'm looking in, because then I would just see nothing basically. My position, my texture coordinates, everything, all of this is correct. So don't let me confuse you like I confused myself here. But now, I think I will figure it out now. I will look at the draw routine by any chance? Come on, look at it. Look at it. Do it. Old me, do it. Notice, notice. Yeah, finally. Good. And now you can see it basically worked all along. I just forgot to call this. Ta-da. Okay. Whew, good. So that's it for this video. Thank you for watching. I hope you aren't as confused as I was. Basically, you can just watch it again to the 15-minute mark. That's all you need to know. Yeah. Thanks.